Hi guys, today we're going to review a little bit on properties of logarithms, and we have a little bit of new stuff too. After we watch the video, we will complete a worksheet if you're in pre-AP, or if you're in level, you will do a delta math. Um, Basic properties of logarithms. This is called exponential form. You have a number to a power equals the answer. And this is the log form for that. Log base A, the answer goes here, equals the exponent. Logarithms equal exponents. Remember that. You should be able to convert easily given one form or the other and converting into the reverse form. Here are some additional log properties. Log base B, any base, log base B of 1 will always equal 0. That's because 3, here's an example, 3 to the 0 power is equal to 1. Starting at the base, the exponent is 0, and the answer is 1, and that is true. 3 to the 0 power does equal 1. Log base B of B equals 1. So in other words, when the base and the answer are the same number, then that value will always equal 1. Here's an example. 9 to the first power equals 9. True. 9 to the first equals 9. Here's another example or property. Log base B of B to the x is equal to x. So here's an example. 7 to the x power equals 7 to the x power. That's quite redundant. Here's one. You just have to memorize this one. I call it the Nike rule. It's b to the log base b of x is equal to x. So I call this the Nike rule because just do it. There's nothing to it. This is the just do it rule. If you have 21 to the log base 21 of 432, there's no work to it. Your answer is 432. So x would equal 432. All right, here are some additional problems that we are going to evaluate. That means, what does it equal? Well, what does it equal? That's what we want to find. So 3 to what power is equal to 81? 3 to what power is equal to 81? You might need a calculator. It's okay. It's actually 3 to the fourth power. So x equals 4. 3 to the fourth power. This one, I'm going to put an x over here. I should have done that instead of putting a question mark. I should have put an x. 5 to what power equals the square root of 5? So we'll have to rewrite the square root of 5 like I showed you a day ago. That would be 5 to the 1/2 power. Now we'll use the 1-to-1 property, x equals 1/2. Here's another one. What does this one equal? We're evaluating. We have 1/3 to what power is equal to 9. 1/3 to some power is equal to 9. Well, 1/3 is 3 to the -1 power to the x power, and 9 is, of course, 3 squared. So we have 3 to the -x, a power to a power. We would multiply the powers, equals 3 to the second power. So once your bases are equal, you can drop your bases and set your powers equal to each other. So -x equals 2, and x would equal -2. All right, and the last one, 5 to what power is equal to 1/25? 5 to what power is equal to 1 over 125? So we want to try to get like bases again. 125 is 5 to the third. 1 over 5 to the third is the same as 5 to the -3. So we have 5 to the x is equal to 5 to the -3. using the 1-to-1 power, x is equal to -3. Just slow me down if you need to. You know, you can slow the video. Common log. The common log is log base 10. When there is no number in the base, it is an understood base 10. So there's a little understood 10 down there. These are the same 4 rules we just did a second ago. 10 to the 0 power is equal to 1. That is true. And when these two numbers are the same, our answer is always 1 because 10 to the first is equal to 10. And 10 to the x power is equal to 10 to the x. And this is the Nike rule. Just do it. There's no work to it. There's a little understood 10, log base 10, and the answer is always this number. So 432 would be our answer. The natural log is base e. When ln is used, there is no number in the base. It's an understood base e. Remember, e is a decimal value 2.71. And we have the same 4 rules as above. E to the 0 power is 1. That's because anything to the 0 power is 1. Natural log base e of e would say e to the first is equal to e. And that's true. And e to the x power is equal to e to the x power. And this is our Nike rule again. E to the natural log base e of 432 is equal to 432. Okay, let's talk about the change of base formula. The change of base formula is a helpful little formula when you can't do the mental math. Like for instance, if I wanted to know what is log base 21 of 57, what would that equal? That means 21 to what power is equal to 57? Well, 21 to the first power is equal to 21, and 21 to the second power is over 400 something. So this can't be calculated mentally. So we have what we call a change of base formula. And to use the change of base formula, we put the log of x over the log of b. Log of x divided by log of b. So for our problem, that would be the log of 57 divided by the log of 21. We would get a calculator out, and our decimal value is 1.33. However, you guys know that in Desmos, there is a log base formula key that you can just plug that into. But this is this is the formula I used when I went to high school before we were allowed to use calculators that had log base in them. We had to do log 57 divided by log 21, and that would give us the correct answer. There are 3 rules that we want to talk about. These are the last 3 properties we're going to talk about. These are called condensing and expanding. So condensing and expanding a logarithm. If I were to give you log base b of x times y, where I'm multiplying 2 things together, and I wanted to split it and separate it, expand it into 2 separate logarithms, it would expand into log base b of x plus log base b of y. So multiplying, I always remember multiplying changes into adding, multiplying and adding. And that's expanding because you're going from log base b of xy to log base b of x plus log base b of y. So if you're multiplying, it expands into adding. And the opposite, condensing, would be if I were to give you this, which is already expanded. And if I were to ask you to condense it, I want you to crunch it back up. So if I were to give you log base b of x plus log base b of y, and I asked you to condense, then your answer would be log base b of x times y. So we're going to get to problems where we're going to do this in a minute. If multiplying and addition should be associated with each other, then dividing and subtracting should be associated. So dividing and subtracting are associated together. So if I gave you a division problem like this, where you're dividing x divided by y, and I said, expand that, separate it into two separate logarithms. It would be log base b of x minus log base b of y. And the one that you're subtracting is the one that's in the denominator. Vice versa. Oh, whoops, I forgot to switch this around. So if I gave this to you and I said condense it, we would be going backwards, and I would see that I'm subtracting, which means dividing. So condensing, I'm just going to write log base b once, and it will be x divided by y. The one that you're subtracting, is the one that goes in the denominator. Okay, the power property. The power property says if you want to expand and you have a power up here, you bring your power to the front of the word log. And vice versa, if you're trying to condense and you have your power in front of the word log and you're trying to condense, then you move that power back up over top of your x, and that would be condensing. Okay, here's one. Let's expand. The directions on this one would be expand, and I'm going to have to write log base 9. I'm going to tell you how many times I have to write it. I have to write it once for the 6, once for the x cubed, once for the y to the 5th, and once for the z. I'm going to have to write log base 9 4 times. So I have log base 9 of 6. I'm multiplying, so it will be a plus. Log base log base 9 of x cubed. I'm multiplying, so it'll be plus again. We're multiplying, multiplying, multiplying. So plus log base 9 of y to the 5th, multiplying, so plus log base 9 of z. Now, that's not completely expanded yet. We have one tiny little detail. We've got to move the 3 in front of the word log and the 5 in front of the word log. When you expand, you're spreading it out. So one more time. Actually, let me just erase it just to save time. Let me put the 3 in front of the word log, and let me move the 5 in front of the word log. Now it's completely expanded. Oh, yikes. Okay, next one. Again, we're expanding. The direction should say expand. So I'm going to have to write log base 3 1, 2, 3 times. Log base 3, I have to write it 3 times. So here we go. Log base 3 of p squared. We're multiplying on top, so we're going to say plus log base 3 of q. Now, anything that comes out of the denominator is subtracted. So minus log base 3, and we've got the 5th root. I'm going to rewrite that 3q minus 1 to the 1/5 power. Remember how I taught you a couple days ago to take it out of the radical? It's the exponent divided by the root. So we have 1/5 power. Okay, the only thing we have remaining to do is to move our powers out in front of the word log, and then it is completely expanded. So we have 2 log base 3 of P plus log base 3 of Q minus